In this video, I'm going to show you how to plot portfolio frontier for 2-stock portfolio and 5-stock portfolio. Remember that the concept of portfolio frontier is very important in introductory finance course when we try to understand portfolio theory and capital asset pricing model. So to begin with, I have an Excel file, and that Excel file has historical monthly stock price for Apple and Walmart, and the start date for the price series is January 2001 to June 2018. And I have hidden few rows here so that I can show you the entire data here, and also I can record the screen. So to begin the process of plotting the portfolio frontier, we have to first compute the return. So let's go and compute return for Apple and Walmart. So that's going to be equals to the current month price that you are computing return for minus the previous month price, right, over the previous month price. So that gives the return for Apple. And now I can grab this little square box and drag it to the right, and that gives me the return for Walmart. And I can double click on this little square box and it computes the return series for both stocks. So once you compute the return, next step is to compute average return for each stock. So let's compute average return for Apple, and next we can compute the average return for Walmart. So that's our second step. So once we compute average for each, now we can compute the variance covariance matrix. And there are multiple ways you can compute variance covariance matrix, but I'm going to follow the process which will be useful when we want to plot the portfolio frontier for 5-stock. That is, I'm going to use Excel's covariance function. So please go to data and click on the data analysis, and you will find covariance right here. Select that covariance and then click OK. And now you have to choose the data range. So once you click on this arrow, and now you can choose all the return series that you are going to compute the variance covariance matrix for. And next you have to choose, okay, I have the levels in the first row. You can select that. Then after output range, where you want to put the output. So for me, I'm clicking on this arrow and I'm going to put that right here. So once you make all that selection, click OK, and now it gives us the variance covariance matrix. And this matrix tells us how these two stocks move together, and also it gives us the variance of each stock. And that's always the lower triangular. This cell right here gives the covariance between Apple return and Walmart, and upper right corner cell also gives us the covariance between Walmart and Apple. So that should be the same. So that two should be the same. So that gives us the full variance covariance matrix. All right. So once you compute variance covariance matrix, in order to plot portfolio frontier, I need a series of portfolio mean and series of portfolio standard deviation. So in order to compute this different portfolio mean and the portfolio variance, I need different set of portfolio weights. So let's start with negative 25% on Apple, and on Walmart 1 minus whatever you have invested on Apple. So that when you add this two, it becomes 100, which means you are using 25% of your total investment on shorting Apple stock, and you are using that leverage and investing 125% of your investment on Walmart. So once you have the portfolio weight, you can compute the portfolio variance, standard deviation, and mean. So in order to help you here, I have a formula to compute portfolio variance, portfolio mean, and I'm going to use that formula to compute portfolio variance. So that's going to be equals to square of the proportion of money you invest on Apple, right, times the variance of Apple plus the square of the proportion of money you are investing on Walmart times the variance of Walmart, right, plus 2 into the proportion of money you invest on Apple times proportion of money you invest on Walmart times the covariance of Apple and Walmart. So the covariance means either the left bottom corner element or right top corner element. So I can choose either one, and that gives me the portfolio variance. And once you compute portfolio variance, the square root of the portfolio variance is the standard deviation of the portfolio, right? And now I can compute the portfolio means, which is the proportion of money you invest on Apple, right, times the average return on Apple plus the proportion of money you invest on Walmart times the average of Walmart. So once you have these portfolio weights, this is how you can compute the portfolio mean and the portfolio standard deviation. Now you can select other different set of portfolio weights, and you can calculate similarly the portfolio mean and the portfolio standard deviation. So I have now different weights that I'm going to use to construct the portfolio frontier, right? So once you have the portfolio weights, you can go and compute the portfolio variance, standard deviation, and mean. So keep this in mind. When you want to compute portfolio variance, standard deviation, mean, what is changing? Only the portfolio weight is changing. Your averages of each stock and variance and covariance is going to be the same, right? So therefore what you can do is you can fix some of the cell in your first formula and leave some cell and then drag it. So I'm going to do that. So for example, what is fixed here? So the weight is changing, right? But the variance is fixed for all the weights. So I can put the dollar sign before that. Later I can put the dollar sign, and that will fix the variance of Apple, and I can go and put the dollar sign before L5, which will fix the variance of Walmart, and I can put the dollar sign before this K, that will also fix the covariance between Apple and Walmart. So once you fix that, right, now you can grab this little square box and you can drag it, and it gives us the variance of this portfolio for these different portfolio weights. All right, now I can do the square root, right? Square root for each of the portfolio variance and then compute the portfolio standard deviation. All right, so I got that too. Now I need to go and compute the portfolio mean. Again, I can use the same formula that I used for. What is changing? Portfolio weight is changing, but the averages are not changing, right? So I can fix this H3, which means this is the average of Apple stock, right? And I can fix H4, which is the average of Walmart. And once I fix it, right, and I can grab this little square box and I drag it to the right, and that gives me the portfolio mean associated with these different portfolio weights. Once you compute this portfolio mean and the variance, you can select the entire set of portfolio mean and the variance, and now go to insert and click on this chart option here, and you can choose one of the chart here, and I'm choosing this guy here. So now this is a portfolio frontier. In order to make this graph look better, you can change some of the features of the graph and make it look better. For example, you can click on this plus sign, and then now I can do the axis titles, right? So now you can type here, the x-axis label is going to be portfolio standard deviation, right? So your y-axis is going to be portfolio mean. So you can also change the limits on x-axis. For example, I want to right click on here and format axis here, and you can change the minimum. For now the graph starts from 0.04 or above, right? So I don't need to start this x-axis from 0, so I can change the minimum to 0.04, right, so that the graph looks a lot better. And another thing what I want to do is see here, the x-axis is crossing that frontier, right? So what I can do is I can go and change the level right here, right? So you can click on this level right here, and then you can select now low When you do that low, that takes the x-axis value below the graph, so the graph looks better. You can also further go and change the color if you like. So these are the things that you can do yourself. I want to emphasize here how we derived and what is its meaning. So let's recap here how we derived. So we had the average of each stock and we had the variance covariance matrix, right? And what we did was we changed the weights, how much money we invest on each stock. We changed that. As we change the portfolio weight, we get the different portfolio mean and the different portfolio standard deviation, right? Then we can plot that series, putting this portfolio standard deviation on x-axis and portfolio mean on y-axis, and this is the portfolio frontier. That means portfolio frontier is a graph that shows the relationship between the portfolio standard deviation, which is a measure of risk, and portfolio mean, which is a measure of return. So each point on this portfolio frontier represents combination of return and the risks. So any points in the lower part of this curve, right, gives lower return for the risk you take as compared to points on the top part of this curve. For example, I want to focus on the second point from the top right corner here. So the portfolio mean for that is more than 0.15%. The standard deviation is slightly more than 0.06. But for the third point from the lower right corner, the mean is almost less than 0, negative, and the standard deviation is the same. That means this point is inferior, inefficient as compared to the top point, right? That's why any point which lies on the upper part of this curve are called efficient portfolio frontier. Any points in the lower part of this curve are called inefficient portfolio frontier. And this concept is going to be very useful in portfolio theory because any rational investor would not choose any point in the lower part of the curve because he is not considered to be rational if he does so, because he can get higher return for the same level of risk he takes if he chooses the points on the upper part of this curve. Therefore, the upper part of this curve is called the efficient portfolio frontier and the lower part of the curve is called inefficient part of the portfolio frontier. Now I want to show you how to construct portfolio frontier for 5-stock portfolio. To begin with, I have monthly historical prices of 5 companies: Apple, Walmart, JP Morgan, Tyson, XOM from January 2001 to June 2018. I have also hidden few rows here so that the data fits within that window and I can record the entire screen. Besides that, I have other text information here which I'm going to use when we move forward. So first thing first, we need to compute the return. Alright, once we compute return, we have to compute average return of each stock, and once you compute average return of each stock, we want to compute variance covariance matrix, and once we compute variance covariance matrix, now we can select different portfolio weights and we can compute portfolio standard deviation and portfolio mean associated with each portfolio weight, and we can plot the portfolio mean and the standard deviation, and that becomes the portfolio frontier. So let's compute return first. Equals to here current price minus the previous price over the previous price. So that gives the return for Apple, and I can drag to the right and then double click it. It gives the return for all the stocks. Now I want to compute average. So average of Apple stock, right? So I can select the entire return series for Apple. Average for Apple. Now I can compute the average for Walmart, right? The average for Walmart return, and next is average for JP Morgan, right? And next is the average for Tyson, and finally the average for ExxonMobil. So once we compute the individual average for the stock, we want to compute the variance covariance matrix. So in order to compute the variance covariance matrix, I'm going to use Excel's covariance function. So click on data and then click on data analysis and choose the covariance function here and click OK, and then select the necessary input. The first one is the data range. Which data are you going to use to compute the variance covariance? And for us, that's our return series, right? So we want to select all that 5 return series, and I do have the name on the first row here, so I want to select this label in the first row, and then next I want to choose where I want to output the output. So click right here and I want to put right here. So once you make all that selection, OK, and that gives me the variance covariance matrix. But the Excel gives us lower triangular variance covariance matrix, and we need the full matrix. So what I would like to do is select the variance covariance matrix and Control C, and I can put it here and right click it, paste spatial, and I want to choose that value and numbers format and transpose it. So what it does is it converts the lower triangular matrix to upper triangular matrix. Now I can copy this guy and again take to the original variance covariance matrix and paste it and make it a full-fledged variance covariance matrix. So right click right here and again paste spatial, and this time value and number, and choose this skip blank cells. So if you do that, what it does is it puts this upper triangular on the top of lower triangular original matrix, and it becomes a full-fledged variance covariance matrix. And now I can delete this. I use this for temporary. Alright, so now I computed variance covariance matrix. Now I want to compute portfolio mean and the portfolio variance, but without portfolio weights you cannot compute portfolio mean and the variance. So what ways would you like to start? I usually like to start with the equal weight. Since I have 5 stocks, so I want to start with equals to 1/5, which means I'm putting 20% of my investment capital on the Apple, and I can drag it to the bottom, so it gives me like I'm putting 20% on each of these stocks, right? So once I have the portfolio weights, now I can compute the portfolio mean and the variance. And for your convenience, I have a formula here to compute the portfolio mean and the variance, and I'm going to use Excel's matrix multiplication functionality. So the first one to compute portfolio mean is the sum product. So equals to sum product, right? Sum product, and your W means weight vector, comma, your mu means mean vector. So that gives me the portfolio mean, and I can compute the portfolio variance following this formula. So equals to M mult matrix multiplication, and I need transpose of the weight vector, right? Transpose of weight vector, bracket close, comma, again M mult, and variance covariance matrix, comma, your weight vector, right? And bracket close, and remember this is Control Shift Enter. So Control Shift Enter, and that gives me the portfolio variance. And in order to use this formula, please make sure that your mean vector and weight vector are like I have here column vector. So if you put the mean vector and weight vector like a row vector, then this formula gets a little tricky. So I just suggest you to put the information exactly the way I have put there. So once you compute this portfolio mean and the portfolio variance, Now we can use this framework to choose the different portfolio weights so that I can calculate series of portfolio standard deviation and portfolio mean, and I can plot this and make a portfolio frontier. Next, our goal is to compute the series of portfolio weights, right? So what I'm going to do is I'm going to use Excel solver function to compute the optimal portfolios in order to calculate the portfolio frontier. So in order to use Excel solver function, I need one more constraint here, meaning the sum of all the weights I have should be equals to 1. Right. So once you have set off, then what you can do is you can use Excel solver function in order to calculate the portfolio weights. So click on data and click on solver. And once you click on solver, you have a window, you have to make certain selection. So what is your objective? So our objective is to always minimize the portfolio variance. So I'm going to select this portfolio variance, and our objective is to minimize, right? So once you set your objective, now you can click on what do you want to change, and I want to change the portfolio weights, right? So I can change the portfolio weights. Now I need to set some constraint, and you can set a different type of constraint, but I'm just choosing two constraints here. One, I am going to choose that sum of all the weights should be equals to 1. Therefore, I am going to say that the sum of all the constraints that I have here, right, this guy, should be equals to 1. That is a very normal constraint. People often put it. That should be equals to 1. And another constraint that I am going to use in order to calculate the series of weight is the mean. So what I can do is I can set this portfolio mean to a targeted portfolio mean, and as I change the portfolio mean, I can compute the different set of portfolio weights, and using that weights I can compute the portfolio variance and standard deviation, and then I can finally plot that. So my suggestion for you would be your portfolio mean right here that you have, right, should be equals to choose one of the returns. Like start with a small return and then increase gradually. And sometimes Excel might not be able to find the exact solution, then you have to do try and error. That's why this is a time consuming process, but I think it helps us to understand how the portfolio frontier is constructed. So to start with, what I want to do is I'm going to set this equals to 0.0002. That is my first return, right? Okay, then I can click OK, and now I have two constraint, and sometime you might see here make on constraint variable non-negative, which is not the constraint I would like to use, because I also want some of the weights to be negative to make this solution more feasible. Otherwise Excel might not be able to solve it. So I am going to untick it, and once you have all this done and click on solve, now it solved for the target return right here 0.002, and now your portfolio weight is not equally weighted. You have a different portfolio weight. So that becomes your first set of portfolio weight. So what you can do now is Control C, and now you can put values and numbers. So that becomes your first set of portfolio weights. Similarly, you can go again data and now go to a solver, right, and leave as is, but change your one of the constraint, which means change the portfolio mean. And I'm going to change now this time to a different numbers, like not 0.002. This time I want to choose to like 0.001, right? So if I do this, now I can solve it again, and now I can find second set of portfolio weights, and now I can copy this here and again right click paste spatial and values and number format, and now I have a second set of portfolio weight. Similarly, you can do third set, fourth set, fifth set, right? You can keep on doing this and you can have as many portfolio weights as you want, right? So for the sake of saving time, I have already computed other sets of portfolio weights, and I'm going to copy and paste it here. So once I have these different portfolio weights, now I can compute portfolio variance, standard deviation, and mean associated with each weight. And I'm going to use the same formula that I have here. To compute portfolio mean, I'm going to use sum product function, and to compute the portfolio variance, I'm going to use mmult function. Let's compute the portfolio variance, right? So that is going to be mmult, right? mmult matrix multiplication, and now this time is the transpose of your weight vector, right here, and bracket close, comma, mmult, and now your variance covariance matrix, right, comma, your weight vector. So bracket close, control plus C plus enter. But what I want to do here, since I want to use this formula in other cell, I want to fix a few cells here to compute portfolio variance for other weights. So what is changing here is the weight is changing, but the variance covariance matrix is going to be constant. So I'm going to fix that variance covariance matrix. So I'm going to put the $sign before this Q4 and $sign before U8. What it does, it fixes the variance covariance matrix, right? Now I can do Control Shift Enter, and it computed the portfolio variance. And this is the portfolio variance for per set of weight. And now I can grab this little square box and drag it to the right, and now it gives me the portfolio variance for all other weights. Now to compute the portfolio standard deviation, what I have to do is square root of my portfolio variance, so that gives me the portfolio standard deviation, right? So I can drag it to the right. So to compute portfolio mean, again, I'm going to use sum product, right? Sum product, and my mean vector, right? My mean vector, comma, my weight vector. Again, keep in mind, I'm gonna drag this here. So I want to fix that mean vector because this is the same for all other weights. So I'm gonna put the $sign before N3 and N7, so I can hit enter, and now I have portfolio mean. I can grab this little square box and drag it to the right, and now I have a series of portfolio mean. One interesting thing you must have noticed here is, like, we have the same stock here in our portfolio. As you change portfolio weights, portfolio mean and the variance is going to change. What you can do now is you can select the portfolio standard deviation and portfolio mean and insert a graph to plot the portfolio frontier. So select the data, go to insert, and click on the one of the chart and select this right here, and now this is our portfolio frontier. You can change the formatting and you can make it look better, as I have done for two stock portfolio. So this is our formatted portfolio frontier, and the red dot here on the frontier represents the minimum variance portfolio, and the line or the frontier above that red dot is efficient portfolio frontier, and the frontier below that red dot is called inefficient portfolio frontier. So I want to recap here how we got that portfolio frontier here. So we had individual average mean, and we had variance covariance matrix, and we computed different set of portfolio weights using Excel solver function, right? So once we have all these different set of portfolio weights, we can compute the portfolio variance, standard deviation, and portfolio mean associated with each weights, and that gives us the portfolio frontier, Alright, now I have another graph. It is also portfolio frontier, but this time what I have done is I included more weights, right? So not just 20 weights I had here, but it has more weights. So when I included more weights and replotted the frontier, this is how it looks like. I have also plotted individual stocks, mean and the standard deviation. So as you can see, all the individual stocks portfolio, mean and the standard deviation are within this envelope curve. So this is very powerful in the portfolio theory. Thank you.